Hello everyone, and welcome to today's SQL Server Pro web seminar, Essential SQL Server Monitoring, Top Issues Identified by Health Checks, sponsored by Datavail. Just a brief note, if you have any technical difficulties during today's session, please press the Help widget on your player console to receive assistance in solving common issues. And if at any time you're having audio difficulties or issues with the advancing of the presentation, simply hit your F5 key to refresh your webcast console. Please also be aware, today's web seminar is being recorded and will be available on demand for 12 months starting tomorrow. You will receive an email when ready. And now, I would like to introduce today's presenters. Michael Odie is Senior Technical Director for Windows IT Pro and SQL Server Pro, and is president of Tekka, a software development and consulting company in Portland, Oregon. Andy McDermott is a principal DBA who delivers and manages delivery of DBA services to many diverse clients. He has also conducted dozens of health checks on a variety of client databases. You can read more about his work at datavail.com/author/Andy-McDermott. And with that, Michael, the floor is yours.
Thanks, Jake. I'm Michael Odie, and today we're going to talk about Essential SQL Server Monitoring. You know, SQL Server, it's a robust and reliable enterprise database platform. But just like your car needs periodic maintenance to keep it running well, there are a number of different points that you need to check on your SQL Server systems to make sure that they well as well. And in this presentation, we're going to cover some of those points as they relate to all the different aspects of SQL Server. But before we jump in, let's go ahead and do a poll and see what everybody out there is doing for their monitoring solution. So, in this poll, how do you usually monitor your SQL Server database? 1, do you use in-house, paid, or free tools? Are you using a third-party vendor where they run monitoring and you make the fixes in-house? Are you using a third-party vendor that's a managed DBA service where they run the monitoring and do the fixes for you? Or are you doing something else? I'll give you just a couple of seconds as you read these different poll questions. Give us your answers, and then I'll check in and we'll see what those are about. And after that, we'll go ahead and launch into the main part of the first part of this presentation. Okay, we've had a few seconds, so let's see what our poll results are like. So, it seems like most people at 75.2% are using in-house or paid or free tools to do their monitoring. A smaller percentage, 5%, are using a third-party vendor to do the monitoring and they're doing their fixes in-house. A slightly larger percent are using a third-party vendor to do the monitoring and the fixes. And 12% are using some sort of other means to do this. Perhaps it's a manual sort of solution where you're not really using tools. That is doable. But anyway, it seems with our poll, most are using in-house or paid tools. So anyway, let's jump into our presentation. And the first part of this presentation, some of the things that I'm going to cover are the SQL Server monitoring tools. And these are mostly tools that come with SQL Server itself or the Windows Server operating system. And there's also one extra tool that is a download that I'll talk about. And these are some of the tools that you can use if you're doing this kind of monitoring on your own. And then we're going to look at some of the points that you need to monitor to keep track of your SQL Server and keep it in good operating health. First, we're going to look at capacity planning. It's important to make sure that you have a growth plan for your system and that you don't run out of either storage, memory, or CPU capacity. Next, we're going to look at some of the important security points to manage. SQL Server is a very secure database platform, but that doesn't mean you just have to let it go. There are a number of things you need to look for there. And then backups are another thing. You might not think of backups as an operational kind of monitoring point, but if you can't restore your system, then you know you've got a problem. So keeping on track of your backups is an essential part of your monitoring plan. Next, there's a number of error logs that come with SQL Server and the Windows Server operating system. I'll dig into those and tell you a little bit about which of these error logs you need to look at, where you find them at, and what sort of frequency you should look at them with. And finally, we're going to talk a little bit about performance monitoring. Performance monitoring is a really deep topic. It's probably more than we can get into with a whole lot of detail here, but I'm going to hit some of the high points of things you should keep track of, and I'm also going to talk a little bit about the importance of setting up a baseline so you can help use that for troubleshooting. So some of the tools that I talk about in the various slides that follow are Performance Monitor. Performance Monitor keeps track of a number of different Windows Server system performance counters, your CPU activity, your memory utilization. It also, when you install SQL Server, it also makes a whole bunch of SQL Server specific instance counters that are in there that you can use to monitor as well. And these are very important when you're doing capacity planning as well as when you're setting up your performance baselines. Another tool that I'm going to talk about is the Microsoft Baseline Security Advisor. It kind of goes along with SQL Server Audit, and you can use it to help perform your security checks for your system. They each have a different purpose. The Baseline Security Advisor is something you have to download separately. SQL Server Audit is built right into SQL Server. It is a very low-impact tool, but I'm definitely going to hit some of the points of things that you should be auditing with your SQL Server to make sure that it's a secure system. I'll also take a look at SQL Server's built-in activity monitor. SQL Server has a built-in tool that you can get through with using SQL Server Management Studio, and it'll show you about all the active processes that are running out there. And then we'll jump into some of those error logs that you should keep track of and look at pretty much on a daily basis to make sure that there is nothing going wrong under the covers that you don't really know about. And this can give you a heads up on it and help keep your system running well. So for capacity planning, what you basically, no database system just runs on a steady stream. Instead, they all have a way of growing. Your databases grow, your workloads grow, the memory that your system needs grows as those workloads continue to increase. So keeping on track of this is important. You certainly don't want to run out of storage capacity. If you do, you'll have a severe problem. You certainly don't want to run out of CPU. If you do, again, your workloads will drag the system down and your things will continue to slow down. So keeping on track of this is an important thing. This isn't something you need to do every hour, though. This is something you kind of just need to track regularly as your system kind of runs. A lot of organizations do this as kind of a weekly sort of task where you just kind of check in, you know, and you record where your system, some very basic system counters were at, and you just keep track from week to week to make sure that everything is the way you expect. And if you see anything that goes out of your normal range, you know where to look for it. Some of those important counters, you can track the size of your databases by using the SP databases stored procedure, part of built into SQL Server. And then some of those performance monitors we talked about, just keeping track of your current CPU utilization. You can use that with the percent processor time counter, and then tracking your current memory utilization. Again, these are performance counters. You can find them under the memory objects section of Performance Monitor, and just keeping track of your available bytes, pages per second, making sure they stay within the ranges that you're looking for. Next, some of the things that you need to look for in security are unauthorized accesses as well as authorized table access attempts. You want to be able to keep track of both. SQL Server is known to be a very secure system. Microsoft touts its security robustness all the time. The National Institute of Standards and Technology has rated it as the #1 most secure database. But even if that's the case, that doesn't mean you don't have to track these things, because your system could be under attack from other things. And there's also from outside influences, and also things that you need to track from just plain the possible security misconfigurations inside and allowing people access to objects that they ought not have. One of the things that many businesses do, if they are in a secure environment, SQL Server has a built-in C2 auditing level that you can set up through SQL Server's audit that will automatically track things at a C2 compliance level. You can also, of course, set up your own security auditing to track your own purposes and for your own business. Some of the security audit points that you may want to look at are listed on this slide. You want to look at any admin authority changes, permission changes to various database objects. You want to make sure you're auditing role memberships when there's membership changes in the roles, particularly your administrative roles. Any security setting changes, if you've reconfigured those. And of course, failed login attempts, that could be a sign that somebody is trying to access your system or hack into it when it shouldn't be. And also you need to track data exports. That could be a way that you could lose important data. So anyway, SQL Server Audit built right into SQL Server. It can track all of these things. You start up audit, and then you can basically pick and choose the different topics you want to audit, or you can just go with the built-in C2 auditing capabilities. Another tool, though, I mentioned it earlier, was the Microsoft Baseline Security Analyzer. It looks at things from a slightly different aspect. It does not have the granularity of SQL Server Audit. Instead, it looks at some common security misconfigurations. Basically, it checks out things like, do you have password policies assigned, and do you have a complex password requirements, and what kind of roles are allowed for the different SQL Server services. It looks at things like that at that level. It's a slightly higher level. There is both a GUI version of this and a command line version that you can run. And for instance, you may want to run this on a regular schedule, so you may want to add the command line to the SQL Server agent job, and if you did it, it would be this mbsacli command here. And again, this is a tool that you have to download separately. Changing gears a little bit, backups are very important to audit as well. You want to make sure that your backups are available when you think you need them. You don't need them until you do, but when you do need them, you really do need them, because otherwise you won't be able to restore your systems. Very important to check. This is particularly the case if you're a DBA and you are managing multiple instances on your own. You need to set up a job where you can track this on kind of a daily basis. The most important thing to look at, there's a number of different ones, but the most important thing to look at is in your MSDB database, there's a DBO backup set. This table tracks the different backups that are being performed on your system. Most important thing, you want to check and make sure that these backups are being performed in the kind of a manner that you think that they should be as you schedule them. So it's very important to check this out on a daily basis. Make sure that your database is being backed up. Nobody wants to have to restore their database, but if you need to restore it, you want to make sure that backup is there for you to get that system restored, and in that case, you need to make sure that backup has been performed. There are also a number of different SQL Server logs that you should check out on a daily basis. One of the most important ones is the SQL Server error log. The SQL Server error log basically records process and completion. It will track backup errors, it will track restore errors, the completion of batch commands, and any other types of kernel errors will be listed in there as well. This is something you should definitely check out on a daily basis at some point. In the morning when you first start, or in the evening, look at it. These logs are maintained in the program files, Microsoft SQL Server, MSSQL.N, and that N is the version of the SQL Server that you're using, and they're tracked in the error log files. There are a number of these different error log files, and at the bottom of the screen, you can look at what the log viewer looks like for it. So you can see all the different logs. You can get to the log viewer right through SQL Server Management Studio. So you can jump into Management Studio, open Object Explorer, open up your management node, go into SQL Server logs, and then view error log. Again, this is something you should be checking out basically on a daily basis, and this will record a lot of different things. If you are not familiar with this, or you're a new DBA, you might be a little bit confused because you might see multiple different versions in there. SQL Server does maintain 6 past versions of the log automatically. It automatically cycles these for you. The current log and what's happening on the system is in the first log that you see here in the bottom that is noted as current. So that is where all today's activities are happening. The agent log is another important thing. Most SQL Server installations do run the agent. The SQL Server agent is an automatic job scheduling system that you use to run a number of different tasks. Many businesses run their backups from it. The agent, like SQL Server itself, it keeps its own log, and it records any completion of jobs and also any job errors that happen. Checking into your agent log is definitely another daily task that you should be doing. Its location here is in the Program Files directory, MS SQL, MS SQL again with your version number, and then it's kept in the log files. Like the SQL Server error log, there are multiple past versions that SQL Server keeps out there. There are, with the SQL Server agent log files, it keeps up to 9 past versions. And again, you can get into this using SQL Server Management Studio. So on a daily basis, you should just get in, make it a habit to go in and check your SQL Server Management Studio, open up Explorer, go into your management node, drill into SQL Server logs, and then find the SQL Server agent logs. And you can see a record of all of the different logs that are running out there. And again, SQL Server Agent is one of those things that you kind of do need to keep track of. It runs in the background, and if there's any errors, they're not always readily apparent. So keeping up in this log file and making sure that everything is copacetic out there is an important daily task to be sure that you do. There are other logs, too, that you need to make sure that you check into. There's a Windows event log. This will record a lot of say integration services or application errors that may happen. You should check into this daily. Again, this is from the Windows side, where you go in from Windows Server's administrative tools, then look into the event viewer. There's often a lot of events out there, so you'll probably want to set up a filter to check out your specific SQL Server kind of events that you're interested in. And also, if you're into installing new systems, there is a setup log. The setup log is not something you need to check every day, but it's something you might want to check after you install a new SQL Server instance. It does contain setup errors. Like I said, you check it after you do the setup. If you're looking to find this log, look into the program files directory, and there's a Microsoft SQL Server. And then again, the version number is specific for what you're looking for out there, but you're looking also for the setup bootstrap directory, and there's a summary text file in there, and that will contain any of your setup log errors. Again, that's not something you need to do daily, but just after you install new instances to make sure that everything happened the way you think it should have happened. Next, we're going to talk a little bit about performance. SQL Server has a built-in activity monitor. You can open this up through a SQL Server Management Studio. Again, you can go into Object Explorer. It works a little differently than some of the others. Here with SQL Server 2014, you need to right-click your instance name, and then the Activity Monitor will come up in the context menu. You can also open it up by using the hotkey Control-Alt-A combination, and that will open up your Activity Monitor as well. The Activity Monitor shows you all of the active tasks that are running out there. It provides kind of an overview of things. You can use it to kill tasks. You can also use it to see who's using CPU. You can check out resource weights. You can see which kind of tasks are having high data file, I/O, and other things. So this is kind of something, if your system is running questionably or there's something amiss, this is probably one of the first things you'd want to check in. You do this kind of as on an on-needed basis. So when you need to check or when you think there's a problem, then you'd open up Activity Monitor and you'd see what was going on in there. And you'd kind of look at some of these points that I talked about, like resource weights and data file I/O, to try to identify something, a job perhaps, that might have some sort of problem with it. Now that's kind of for daily tasks and for ad hoc troubleshooting. One of the things that's really important when you're looking at keeping your system running well, though, is to perform performance baselines. This is something you should basically do. It should be captured or on probably a weekly basis. At certain times, you want to capture your normal system activities, which means you're basically looking at getting your typical workload. You're looking at when you're running normally, and also you want to capture a few when the system is running at high resource levels. So just so you get an idea of what's normal. This can be a really important troubleshooting tool because it can allow you to pinpoint anomalies. You can see what's different because you have a baseline, you're tracking certain performance monitors, and then you can see quickly by comparing your current utilization to this past baseline if there's any abnormalities or if something is way out of whack. Creating a performance monitor, or a performance baseline, you'd use Performance Monitor to do this. You typically create something called a data collection set where you tell it what kind of things or monitors you want to track. You include them in this data collection set, and then you can schedule this to start and stop automatically. There's a lot of different Windows counters you may want to look at, a lot of different SQL Server counters. Here I've given you a list of some of the most essential ones. Of course, the processor time, page file utilization, disk time. The disk counters are probably more important if you're using DASD, not so important if you are connected to a SAN. Again, checking your network interface counter to make sure that you're not overdoing your I/O bandwidth capabilities on the network. Some of the core SQL Server counters you might want to look at would include SQL statistics, batch requests a second. That just basically tells you how busy your SQL Server system is. Buffer cache ratio is also an important counter. Tells you how many times SQL Server is able to get requests out of the buffer cache. Very important for this to be a very high rate. And then there's a buffer cache list stalls per second. That tells it how many times SQL Server can't get things out of the buffer cache, and it has to go to disk to find them. There are a lot of other excuse me. There are a lot of other counters that you can look at, but those are some of the core ones. And some of the additional resources that I have here will help you get a more complete idea of what you're going to look at there. So if you want to look at monitoring resource usage, you can check out this URL in this one. If you want to look at some good resources for monitoring table size growth in SQL Server, there are a couple interesting stored procedures you can grab out at this URL that can help you do that. And of course, you can download the baseline security analyzer from that URL. A couple other additional resources that you might want to check into. There is a nice thing on SQLmag.com, a nice little stored procedure for checking the backup status for multiple SQL Server systems. There's also another tool out at SQL Monitor on Codeplex that you can look at. There's a very nice guide for establishing a performance baselines that are out on TechNet. It's meant for an older version. I think this was a SQL Server 2005, but it still applies today. And then finally, you can look at scheduling and managing data in Performance Monitor for some basics about how you might use Performance Monitor to get some of these statistics. So some of the key takeaways, though. First, SQL Server it runs on its own and it does a good job, but you can't leave it to run on its own forever because things will definitely go wrong. Regular health checks are essential for keeping your SQL Server system running at its top. Capacities, you want to check out performance. It's important for making sure that it's highly available. It's important for making sure that your system is secure, and also important to be sure that you can recover your system and to help you troubleshoot jobs. So regular health checks are essential for keeping up with your SQL Server system and keeping it in top operating condition. That's it for my portion of the presentation, but I know we also have a poll, and I will present this poll to you, then I'll turn it over to Andy. And our first poll, or our second poll here, is how often does your DBA team perform health checks on your SQL Server database environment? 1 to 2 times a year? 3 to 4 times a year? We don't do health checks, or I don't know. I can hope it's not that we don't do health checks section. Anyway, that's it for the poll. And now I'm going to turn it over to Andy, and he'll deal with the results.
Hi, everyone. This is Andy. Let's just look at these results. They're already up. So how often does your DBA team perform health checks on your SQL Server database environment? 1 to 2 times a year, that's 21.2%. 3 to 4 times a year, 27.9%. We don't do health checks, almost 30%. So fairly even numbers there, and I don't know. Nobody doesn't know. Well, thank you for joining the webinar today, and thank you, Michael, for your presentation. I think it's interesting that Michael's presentation on monitoring includes aspects of my topic, which is health checks, and my presentation on health checks includes monitoring. So there's a lot of overlap there, but I think having these two perspectives, different perspectives, will be a good thing. So anyways, we have some ideas on essential monitoring for SQL servers, and we know what to look for. Let's zoom out a little bit and take a look at the broader topic of just general SQL health. My name is Andy McDermott. I'm Principal DBA here at Datavail, and there's a few ways to reach out to me. You're welcome to contact me if you like. So I broke down SQL Server Health into these 4 categories to get kind of a complete picture of, I guess, what overall SQL Health could be. First of these is monitoring. Part of the health is actually looking at the health, so we need to keep an eye on the whole system, and that's part of keeping it healthy. So my definition of monitoring, this is mostly like an automated monitoring. It means what's going on right now. Is the CPU above a certain threshold? Is there a missing backup or a failed job? Next one is maintenance. What needs to happen on a day-to-day basis to keep an instance healthy? Examples, of course, of backups and maintenance, as well as a bunch of other simpler things like cycling the error log. Setup is another topic. Anything a DBA might set up after the instance is installed. Things like replication or mirroring or the auditing Michael mentioned, or log shipping, general security configuration, and of course physical layout and configuration of the database files. All these things are part of setup. And lastly, configuration. This includes all the options exposed in SQL Management Studio or via the SP configure stored procedure. These can be things that really need to be addressed where the default values are not okay for these configuration options. A good example is maximum memory. Typically that default value is not okay. Or things where the default value is okay, and in fact it might be a good idea just not to touch these configuration options at all. A recovery interval might be a good example there. So with all these categories in mind, let's dive into some examples and take a look at what's out there in the wild, and we'll take a look at a few examples within each category, what automated monitoring might miss, and what a more complete evaluation might uncover, and finally look at options to collect, analyze, and on all these things. So here's an example of what automated monitoring usually looks like. Some process runs locally on the SQL Server and captures these values. If any of these values are over a certain preset threshold, the DBA gets an alert. So these are probably familiar to most people: disk, CPU, and memory utilization, service status, is it up or down, database statuses, is it recovering or online, backup statuses, job statuses, etc. So we touched on some of this already in the presentation, so we're not going to spend too much time on this stuff, but instead we're going to look at what this automated monitoring can miss and other options on SQL Server that we need to pay attention to. And that brings us into this maintenance category. What processes or procedures need to happen on a regular and recurring basis to keep an instance healthy? So here's a partial list anyway. Backups, of course, are part of this. Index and statistics maintenance, consistency checks, and a whole slew of housekeeping tasks like cycling the error log, purging the database history tables, and so on. So let's take a quick look at a few of these. So we know general monitoring will pick up on a missing backup, but what about a case where backups are successful, the database is in full recovery mode, but there are no transaction log backups happening? So that's not too good. Either the database needs a transaction log backup job setup, or it needs to be put into simple recovery mode. Otherwise, with that full recovery mode, we risk an outage if that untruncated log that's not getting backed up fills up the transaction log file or even the whole disk. Along the same lines, a close look at backup configuration might reveal the backup destination to be on a local disk. So this, of course, is a disaster recovery risk, since if the disk or the whole server goes down, those backups are lost as well, and there may be no way to recover that data. Another classic case of misconfigured backups is when retention days are set too low. So depending on your environment, best practice says to keep at least several days of backups on hand. Usually that means a two-step process. First, back up the database, and then a cleanup step to delete the oldest backup files. But what can happen is, as the database grows and the backup disk fills up as the backup file sizes increase, that can start to fill up. So to solve this, rather than adding disk space, one easy resolution is that retention days get decreased. So from, say, 7 days, it gets knocked down to 5. down to 3, and then maybe even down to 1, just to make space so the next backup will succeed. So in some cases, sometimes I've even seen it where someone has the idea to run the backup cleanup step before the backup. So there's definitely room for the next backup there. That solves the problem, but of course now there's a gap since there's no backup at all saved in between the cleanup step and the backup. So it might not be likely, but what if something goes wrong between that cleanup step and the backup? You're left with no recovery. Automated monitoring might pick up a long-running process or blocking, but it can't necessarily find the root cause. Sometimes these issues might be due to unmaintained and fragmented indexes or out-of-date statistics. It's important to keep indexes maintained, to keep queries running efficiently. So the first step is to ensure there's an index maintenance job at all, and oftentimes there's not. It can be really easy and a quick fix to just throw in a maintenance plan or something to handle that work. At least you're covered. If, on the other hand, there is an existing index maintenance job, you can start looking at it more closely, making sure it runs frequently enough to keep the fragmentation to acceptable levels. Also, you can dig in a little deeper and start considering improvements to the index maintenance process to make it more efficient. For example, it might be a good idea to ignore unused or very small indexes during the maintenance. Similar to index maintenance, statistics also require regular maintenance to keep queries running fast. SQL Server builds its query plans, or its path to the data, based on statistics, so it's very critical that the statistics are kept up to date. Again, the first thing to check for is if the SQL instance even has a statistics update job, and then dig in and determine how it might be optimized or best used. So another regular maintenance procedure might be a health check report, kind of like we're talking about today. That would certainly help keep an instance healthy if we had a regular report coming to us to keep us informed of all these kind of configurations and setup issues. So after initial runs of this kind of report, identify health issues, and those are resolved, a regular recurring health check report can help keep the SQL instance up to the standards that we set for it. So the other cool benefit here is if we archive those reports, they can keep a history of the SQL instance health over time, and this can be really valuable to be able to look back on the history of the instance health, see if it's improved, stayed the same, or has the health deteriorated, and then focus in on what might be the cause of that, especially if it stayed the same or deteriorated. So we'll get back around to a little more on health check reports later. But for now, let's move into the setup category. So what physical and logical aspects of an installation contribute to SQL instance health? This is really a catch-all category. There's so many things to be included here. But here's a quick look at a few things to consider. Are there more than one SQL instances installed on the OS, on the server? What other services, including SQL services, are running on the server? How is security configured? Is it up to best practices? Is replication configured? Is mirroring configured? Or is there any other features of SQL Server configured and running? Also to consider here is our disk and database, our database files isolated from the OS files? Are data files and logs files separated because they have a different I/O profile? And is TempDB on a dedicated drive, because it too can benefit from being off by itself, I guess. So there's many, many more, but we'll just take a look at a few of these considerations. So for a brand new database growth settings come from the model database, which acts as a template for all the database configurations. So you have to start somewhere, but the defaults that are coming from the model database are not usually optimal for a typical database use. One thing to look at is a default auto grow for a data file is 1 meg. So you could argue that this reduces the grow time by just keeping these small growth increments. You just get very many of those. But in some cases, if you have like a database where a lot of stuff is getting a lot of writes going to that database, this can lead to an almost continuous growth pattern, and that's stress on the system. Additionally, each 1 meg chunk of that file as it gets added is get written to a different part of the disk. So now that results in disk fragmentation, that 1 meg chunk of these database files are kind of all over the place. Similarly, the default auto-grow rate for a log file is 10%, so there's some similar problems here. If the log file is very large, that means large and time-consuming grows. On the other hand, small growths lead to a high virtual log file count, and we'll look at virtual log files next. So remember, anytime a log or a data file needs to grow, SQL locks that file and everybody waits for the grow to happen. So while it's good to have these auto-growth parameters configured the best we can, just in case there is a grow during business hours, it's much better to manage these file sizes manually during a maintenance window. So there's a two-part thing here. We want to look at how much free space is available in that file, how much we think we need, and if it does get full, then what are the auto-growth settings that are going to get kicked off potentially during business day. So we're trying to tune the whole thing to have the best possible scenario. So getting back to log files, let's look at virtual log files, also known as VLFs. VLFs are a kind of internal management unit within the transaction log file so that SQL can determine which chunks of the log file can be truncated and reused. So if you have a very many small log file growths, like we discussed earlier, this can result in many VLFs. Too many VLFs can reduce recovery time, since the SQL Server must read each VLF as it recovers to decide which VLF it needs to roll forward. It might find an empty one, and it can skip that, but it has to check. So it has to check each one of these, and it can really extend the time that extend the recovery time. Let's look at one more aspect of our setup category, TempDB files. By default, of course, TempDB comes with only a single data file. However, since it's a shared resource, it's possible that many tasks may be trying to access that TempDB at the same time. To use TempDB, each task must first find some unused space within that file, and they do that by looking at a couple special database pages, GAM and SGAM pages, to find where the free space is that they can use. So if many tasks from many different using other databases are trying to access these SGAM and GAM pages at the same time, this can result in what's called TempDB allocation contention. So the remedy here is pretty easy. You just add TempDB files to spread out the load. There's more on this in the reference. There's a link to more on this in the reference section, as well as some other reference stuff here in my presentation. So you can find out more about that. Okay. Anyway, it's not always that easy. Many of these setup issues that we just touched on here are pretty complicated and might require a longer-term planning. It can be a bit of a long road to resolve them. So we'll move into the configuration category. Under this category, we're looking at all the options to configure the instance and databases. So there's about 70 instance level options and about 30 database configuration options. So there's no shortage of things to consider here. Let's look at a few instance and database options. So here's max memory. This 2 billion number is the default setting right out of the box, and that just indicates that the instance is set up to use memory dynamically. So this configuration option sets the buffer pool size, and SQL will keep taking memory from the server up to whatever is available on the OS. But we don't necessarily want that. We want to cap SQL at some point, so we still allow a reserve for the OS and whatever processes are running. So here's a quick rule of thumb to set that up. This reserve gives you an idea of how much the OS might need, and then you can grant the rest to SQL Server. You can start with 1 gig of RAM for the OS, add 1 gig for each 4 gig of RAM installed from 4 to 16 gig, add another 1 gig for every 8 gig of RAM installed above 16 gig. And again, you can look in the reference section for a great blog that goes into this a little deeper. So here's our next minimum memory. It's set to 0. Again, the idea here is to allow SQL to dynamically adjust its memory usage, but we don't really want that in a production system. We don't want other processes able to take memory away from SQL. So one idea here is to set minimum memory equal to maximum memory. And now we've essentially reserved a fixed amount of memory for only SQL to use, and we don't have to worry about any of this dynamic adjustments going on. So this wouldn't apply in every case. You'd really want to make sure you had your maximum memory set perfectly, and you want to make sure you didn't have other processes that might need to share memory now and then in this case. So it's a bit of advanced technique. You'd really want to dig in to make sure you got your T's crossed before you apply that, but in the right case it can really work well. Next thing we're looking at here is the max degree of parallelism. So this setting allows a query plan to potentially use up to the logical CPU count for parallelism. Parallelism is just a way that SQL Server can spread out a larger piece of a query among different CPUs, and it can increase its efficiency of the query plan that way. So the limit is actually 64, but regardless, this may not be optimal for instances with many CPUs. We just don't need that many. Instead, the recommendation is to dial the max degree of parallelism down according to how many NUMA nodes the server has, which kind of makes sense. If you do have, for instance, four CPUs per NUMA node, you might like to keep those 4 threads on the same NUMA node so that all that memory is local. There's a quick equation here to figure that out. So if you had, for example, 16 CPUs and 4 NUMA nodes, you'd set your max degree of parallelism to 4. So now we'll move into some database configurations that we sometimes see misconfigured. So the auto close setting, you see this a lot of times on sometimes databases have been around a while and might have been migrated over from MSDE versions or even SQL Express versions, and that's where the auto close is actually the default setting for the database there. So when those databases get migrated over to, let's say, a bigger production instance, they bring these settings along with them. Auto close, anytime anybody logs into the database, it opens, and anytime it closes. So that would save resources on your desktop, but on a production instance, it's just extra overhead, not necessary. The auto shrink setting is actually very problematic. You don't have to Google around too much to find examples where it says don't turn this on. What's going on is a background process runs every 30 minutes and examines the database files, and it wants to see if there's free space in there that it can take and give back to the operating system. So if it does find free space to try to recover, it takes the full pages from the end of the database file and moves them back towards free spaces in the front of the file. So this causes a lot of fragmentation, and then of course if your auto grow settings are not ideal, the file might just have to grow again anyway as more things are inserted. Now you just have a back and forth shrink, grow, shrink, grow, and that just burns up CPU and causes that fragmentation I mentioned. It's really just a lot of unnecessary overhead. So a quick aside here, there's one, this policy-based management is included in SQL Server, and it's really a great tool to keep tabs on a lot of these configuration options. So once you've defined how you want a particular option to be configured, or a set of options, you can build this as a set of policies in policy-based management and evaluate that overall configuration. Each policy is designed to either pass or fail, so upon evaluation you get a good quick picture of what's out of line and what's okay. It's a great way to keep tab on some of these simple configuration options, especially so you can really keep track of this low-hanging fruit and address it quickly. Okay, so by now, hopefully I've convinced you that there's a lot going on in SQL Server Instance, and many things need a deeper and more careful look above and beyond just what a basic automated monitoring would kind of give you. So now that we know the kind of things that we should be looking for to keep an instance up to good standards of health, the question is, how can we get a grip on the overall SQL instance health day to day, or every month, or at least regularly? So we need a comprehensive review of everything we've covered here, and more, obviously. But although the evaluation itself needs to be very comprehensive, we don't really need that level of detail. We just need a summary view. We don't need every little detail or a total rehash of all the information available in SQL Management Studio. We just need kind of a summary look to see what's good and what's bad. And then ideally, of course, we want to automate that delivery so we can review this report regularly. Of course, then too, we can't forget to set aside some time and resources to take a look at the report, see what's out of line, what needs help, and schedule those changes. There's a lot of health checks out there, but that's kind of the direction we're going with what we want to do in our health check. We borrowed the basic kind of idea I explained in policy-based management, this pass-fail idea, so you just get a sort of a quick overview of what's wrong and what's right. We set up parameters for each aspect of SQL Health, organized those aspects into different categories, and wrapped everything into a summary report, and then we deliver it via SQL Server reporting services. So that's about that. If you want to learn more about our SQL Server Health check, please look at the resources section on the console here for a link to our white paper, or go to datavail.com/resources. And if you'd like a chance to win a free health check, you can contact Kelly here at Datavail, and she'll get you set up. And let's see, we have one more poll here to do, and that is, what are the main challenges you find when you performed a health check on your databases? Choose 3. So we'll hang out a few minutes and let that poll get filled out. So we have some results back. It looks like so far missing or duplicate indexes is a big issue. And missing backups. So 50-50 split there. Interesting. And yeah, that's about it from me. Thanks very much. We'll be taking questions for a while. This last slide here is just a bunch of references and additional information if you want to dig into anything I talked about here. Some more, just those links, and feel free to contact me via my contact information on that earlier slide if you have any other questions.
All right, thanks a lot, Andy. And before we do begin the Q&A session, I would like to ask the audience to please take our survey by clicking on the red survey widget on your audience console. A few of you have submitted questions already, so we're going to jump right in. We have about 10 or so minutes for Q&A. And here's our first question. What kind of issues will a health check find that a regular monitor would not?
Yeah, hey, this is Andy. So we kind of went over that in the slide presentation, and a lot of that stuff is really configuration options and different ways that SQL Server can be set up. So the more we can look at those configuration options and get that stuff right, or as right as we can, we're actually reducing the monitoring and alerts and monitoring. So we're kind of reducing the load on the monitoring system by figuring out where we can address setup issues and configuration issues and maintenance issues. I hope that answers the question.
Thanks a lot, Andy. Here's our next question, and this one I believe is for Michael. Michael, doesn't C2 audit cause excessive SQL log growth, which in turn causes performance issues?
Yeah, I'll handle that. C2 audit mode is a resource-intensive mode. When you use it, it is something that you would have to choose that your system has the capacity to perform it, and that you actually need that level of auditing with your system. Some very secure installations do. So it's not something for everybody. C2 auditing definitely does have a performance impact, and you should evaluate whether you need that level of security before turning it on or not. So it is definitely, performance is a consideration with C2 auditing.
All right. Thanks a lot, Michael. Here's our next question. When does the error log cycle and SQL Service restarts?
I'll take that one too. This is Mike, and the SQL Server error log recycles every time you restart the SQL Server instance, or optionally there's a stored procedure called SP cycle error log that you can run that will also cause the error logs to cycle.
All right, thanks, Michael. The next question is, do you recommend any third-party tool for this? That's for Andy.
Yeah, this is Andy, and so we have a health check report that we recommend because it's our health check report. But there are quite a few out there, and you can probably Google around and see what else is out there. There's some good solutions, but yeah, we'd be happy to help you out with that if you want to contact us as well.
Fantastic. Thanks a lot, Andy. Here's our next question. I have a customer that runs statistics every 2 hours on our database. I think it is excessive as the changes within 2 hours, what changes within 2 hours, never mind existent. Is there any recommendation around the frequency of running stats? Is this too much, or should we be doing it less?
So this is Andy. It's kind of a tricky question because it can be valid to run stats that often, depending on the table, how big it is, how often it gets updated, etc. You really have to dig into the next step and see what's going on. So that can be valid if it's running every 2 hours for every table, every index. That probably is excessive. There's ways to scope it down and target specific things, specific indexes that really need it, and then either allow SQL as an auto update stats that can handle a good part of statistics updates, or like I was explaining, a daily or weekly job or something that kind of handles everything in general. So yeah, it can be valid, but it should be specific and targeted down to one index.
Fantastic. Thanks a lot, Andy. Here's our next question. What are the top 3 misconfigured items that you see that most adversely impact performance? And I believe that could be for both of our presenters.
Well,
sure.
I'll jump in just briefly. I think Andy touched on this in his presentation, and that is the importance of having autogrow configured appropriately. Autogrow is probably one of the biggest things. As Andy mentioned, SQL Server halts whatever's happening in that database while those autogrow operations happen. That's definitely one of the first things to look at. You don't want that to happen frequently, and I think that's one of the things Andy was getting at. Do you have one, Andy?
Yeah, totally agreed there, and I would just say that so often it does come down to index maintenance or stats maintenance as far as just getting the queries to execute as fast as possible. Sometimes it's just a basic maintenance issue. You just have to tweak it a little bit, and you can get quite a bit of bang for your buck out of it.
Great. Thanks a lot, gentlemen. Here is our next question. Is there a default health check report that can be shared with us?
From a Datavail perspective, if you contact Kelly, on that last slide, she can probably hook you up with some kind of default, or at least tell you how to get started with us on that.
Great, thanks, Andy. What is the impact of online index rebuilding on current transactions?
That's a good question. I can't say I have an immediate answer for you. It is an online rebuild, so the current transaction should run just fine. It shouldn't experience any blocking, but there's a lot going on under the system there that I don't want to dig into too far, too deeply.
All right, thanks a lot, Andy. And I believe this could be for both of our presenters again, but what is your opinion on using traceflag 2371 to change the auto-update stats on large tables?
This is Andy, and yeah, that one's out of my wheelhouse. Also, I'll have to look that one up. Thanks.
Yeah, that is something that you'd have to take offline. I'm not familiar with the benefits of using that particular trace flag.
Okay, thanks, gentlemen. Next question, what is the average downtime when performing a health check? And I believe that's for Andy.
Yeah, hey, this is Andy. So really there is no downtime. Certainly it can be impactful. It can take some resources, so we'd want to schedule it for a maintenance window or a quieter time off business hours, but there's no downtime.
All right, great. Here's our next question. What may be involved with having an external partner to perform a health check, like granting systems admin access?
Yeah, that's a good question. For our health check anyway, we do need sysadmin on the server and local admin on the server box. Sorry, sysadmin on the SQL Server, local admin on the box, and there's a few other requirements like PowerShell and whatnot. But if you contact us, we can get you better details, at least on what ours requires.
And thanks, Andy. And then we had a question as well about what usually happens after a health check. After it's completed, what are the next steps that usually happen?
So again, from our perspective, we just review the health check, and if we're working with a client, we kind of pick off the low-hanging fruit, what we can change quickly and easily, and then develop a plan where we can start making more, deeper configuration changes as needed. So we just start stepping through it and try to get it to the most healthy place we can.
Great, thanks a lot. And it looks like we have time for just one more question. Is it possible to view the error log entries as records?
This is Mike. I assume that means as entries in a table, and the default is that all these error logs are actually text files. So they are not tables in SQL Server, but being that they're text files, you could either manually set up something like a script in PowerShell to import them to a table, or there are various third-party tools that can do that as well.
Yeah, let me jump in there too. The XP read error log, or I forget the name of it, but yeah, you can actually read the error log as a table as well using a extended storage procedure.
And great. Before we log off, Andy, one more question for you. Could you repeat where attendees can go today if they want more information on Datavail products and any questions they may have for you and your team? Yeah, sure. You can go to datavail.com/resources, where we have all our resources put up, or you can email Kelly, KELLEY, Weir, W-I-E-R, at datavail.com. Or email me, andy.mcdermott, at datavail.com, and we'll try to help you out. Fantastic. Thanks a lot, Andy. And I am afraid that we have run out of time for this web seminar. I would like to thank Datavail for making today's event possible, and I'd also like to thank Michael and Andy for their great presentations. Just a reminder, this seminar will be available on demand starting tomorrow, so feel free to come back and review. Have a great day, everyone, and thank you so much for attending.